I can't hear the students. All you can hear is Mr. Murray shouting at people to be quiet. The car that might be going down Stirling Highway is doing 60 kilometres per hour. A plane can travel 900 kilometres per hour, and the speed of sound in this room right now is travelling 342 metres per second. I would like you to convert. And look, I'm even going to make it that much easier for you. To get to kilometres per hour, we times by 3.6. To go back to metres per second, as I just said, we divide by 3.6. Please do that now. Get your calculators out. 1 decimal, 2 decimals, it doesn't matter. Once you've found a value, you might want to just calmly sound out the action and the speed, if you've solved for one. Indy, have you solved for any of them yet?
Yeah, I've done walking meters.
What is it?
1.38.
It sure is. Anyone else want to start adding this in? Go Ed. 3.3 metres per second. Yep. Anyone else? Peter Carstens? Give me something.
I just did a plane.
Mm-hmm.
And then it's 250.
It sure is. 250 metres per second. So once it gets up into the air, it's chuffing along. It's travelling 250 metres every second. Someone else. Let some of the less apt students have a chance, Ed. Yes?
For the sprinting, it's 3.36.
36, that's better. 36.0, really, isn't it? 36.0. And something else? Yep. Go. No, come on, Ed, then.
The sound is
1,231. And then who's got the car? Yep. 16.6. All right. Good. Just remember, could I get you to add down the bottom here? Note, working out must be shown in tests. Okay? And from this point forward, we're going to be using, I tell a lie. We can use kilometres per hour and metres per second, but if you have to convert, you have to show the working out. If you were given in a test this number here, but you wrote down this number in the equation, you'll lose a mark because you haven't shown all your working out. Remember I said, if you use that calculator for any reason, what you write in the calculator must be written down on the paper, okay? Because marks are awarded for showing working out. All right, turn the page. Here is some important rules. And from this point forward, even the Year 12 ATAR students are going to be using these rules. Again, I will tell you why, because marks are going to be awarded for a lot of this. Now, thank you. Yes, from now on, you might want to add the W. Gentlemen, what I'd like you to do is to highlight or underline the important information. Okay? Or variables, the variables that are given. You might be given a paragraph and it's talking about Toby walks 500 metres from the shops to school. You don't care about Toby. You don't care where he started or why he's walking to the school. All you're caring about is the distance and the time and the velocity. Okay? Next, you are going to write them. I'm just going to change the font to try and get this to match. Whoa, that is too much. Let's go down a bit. Next, you are going to write them down on the left-hand side of your page. Okay? So you find the variables and you write them down. Next, you need to convert any units if necessary. If necessary, you need to convert units. This has to be shown. Even things like converting grams to kilograms. If you're given 500 grams and you write 0.5, In a WACE exam, the year 12s, if the year 12s just write 0.5, because in your head you can convert 500 grams, yeah, it's 0.5. If you don't write it on the page, you lose marks in the WACE exam. All right, so start now. Good habits, start early. I'm gonna have to. Let's just. It doesn't line up. Next, you are going to pick the correct equation for the unknown variable. You know, if you're solving for S, you're going to use the S equals. If you're solving for V, you're going to use the V equals. Okay? Then you are going to substitute the known values in. And then lastly, I understand, what if does that make it, no, that makes it worse. Nah. Everything's working against me. Lastly, you are going to remember units and direction if a vector. So, if you have a vector value, you have to remember the direction. Velocity might be west. Displacement might be east, if that is what you are solving for. Okay? I can't get any other font sizes, can I? No. Okay, so let us use these rules for the next couple of, well, just this question, in fact. So you got all that written down? We're going to go, we've got that, and we've got that. 3 things. We've been given 2 values, and we've been asked to find for the unknown a 3rd value. Could somebody tell me, 4 meters per second, is that V, S, or T? It's V, it's the velocity. 60 seconds, is that T or S? T. How far? Is that S or is that S?
Yes.
It's S. So that's step 1. Now, for now, we're going to underline them, and I'd like you to identify which variable. As you get better at this, you don't have to identify the variable. We're going to go over here. V equals 4 meters. We'll just go 4 meters per second. T equals 60 seconds. S equals question mark. So, I've just done step 1. I've just done step 2. I don't need to convert any units yet. We'll learn about that in the rest of today's lesson. So we don't need that for now. Now, we've got to pick the correct equation. We need an equation that starts S equals. Do we have an equation that starts S equals? S equals V times T. So I'm going to write that down. S equals VT. S equals VT. I am then going to substitute in the values. That's going to be 4 times 60. And then I get my calculator out, and my calculator tells me 240. I'm solving for distance. I'm going to have to include the units of meters. Okay? Now, we were not given... Oops, I'm trying to write in that blooming text box. What's going on here? Oh, no. You son of a gun. Yes. Now, we weren't given the velocity. We don't know what direction he's running. He could be running around in circles. He could be running around the classroom for 60 seconds. Okay, so we're going, all right, I've given the speed. At most we can find is the distance. If it said 4 meters per second north, then that means I'm displacing myself north. Okay, and that would be a vector. But for now, we're not given any information. All right, gentlemen, converting units. This is important. It's not in the syllabus, but you need to know this very important skill. We've got our equations. Let's just write them here just to remind ourselves. V equals S over T, S equals VT, and T equals S over V. Those are our 3, okay? Now, we need to be aware of the units. If I have meters divided by seconds, then my speed is meters per second. Alright, see, I put them all in that column. If I have distance in kilometers and time in hours, then my speed would be kilometers per hour. Okay? Now here's the thing. All of my units have to be in one column or the other. All right? So here's the problem. We could have time in minutes. Well, I would need to convert it either to hours or seconds. Okay? So here's the thing, gentlemen. If I gave you distance in kilometers, time in seconds, and asked for speed, well, here's what I could do. I could convert my time into hours, and then my speed would be in kilometers per hour. Or I could convert my kilometers to meters. And then what would my units of speed be? Meters per second. Okay? So that's the issue. Sometimes you will be given a unit that doesn't fit. You've got to make sure that everything is in either column. Yes?
Would you, if you went seconds and kilometers, would you put the kilometers to meters? Or
You could do that. So, for example, if we had time in seconds, distance in kilometers, and you wanted to ask, S equals, I would go bump him across, divide by 3.6, and then when we solve, then our units will be in meters. I can put him there. Okay? We'll look at this now with some examples. Okay, and remember for minutes, well, we're going to times by 60 to get to seconds, or divide by 60 to get to hours, if you were there. Okay? All right. Now, this is the fastest I've ever run 12 Ks. I'll never be able to replicate it because I'm old and injured. All right? Now, I've got distance is in 12 kilometers. Time is 49.5 minutes. And we want to find my speed. So, that should be minutes. All right? So here's my problem. If we go back to the previous page, I've got minutes and I've got kilometers, and I need either units. Now, what's the easiest thing to do here? Thank you. Yes, that is an error. My bad. There we go. Sorry. I know, and you all followed me blindly down the rabbit hole. Sorry. Okay. What are we going to do? Ed?
Make it 12,000 meters instead.
Okay, we could convert it to meters, but look, my time is still in minutes, right? I'm still going to have to convert. Now, your method would work. We could convert distance to meters. We would still have to convert time to seconds. That's 2 conversions. I think there's an easier one. Yeah, change it to hours, right? And then my answer will be kilometers per hour. Okay, now you could do that, but we're going to go this way. What we're going to do, we're going to divide by 60, and that will give us a time in hours, and it comes out to be 0.825 hours. Now, when I solve for velocity, we're all in the same column. So my equation, V equals S over T, 12 kilometers divided by 0.825 hours. Again, sometimes the units can stay in the equation because really they're combining themselves as well. The numbers will combine themselves. You'd work out this as a numerical fraction. You get your calculator out, you go 12 over 0.825, and it spits 14.55. But these units are also going to play with themselves. Think back to maths, think algebra, think your power rules. We've got kilometers divided by hours. That's kmh to the negative 1, kilometers per hour. Okay? But I don't care. You do not need to include the units. You could get rid of them if you want. You can just evaluate the numbers and then realize that we're solving for velocity and those are our units. Okay? If I hadn't have converted, it would have been kilometers per minute. I could have done 12 kilometers divided by 49.5 minutes, and that would have been 0.24 kilometers per minute, which is not a useful unit. We want either meters per second or kilometers per hour. If I wanted to figure out that in meters per second, I can still use my conversion. Our conversion was you divide by 3.6, and that will give 4.04 meters per second. Okay? All right, next. We're going to use all of the rules, the columns rules and the steps from the previous page. A person runs at that rate for this time. Question is how far? V, T, S. 4.5, S equals question mark, T equals 20 minutes. Now, Ed, I reckon you were onto the right thing here. If we go back to our columns, we had meters per second, minutes, and we want to get either how far. So, now we could convert minutes to seconds. If I bump him across, then we've got meters per second, we've got seconds, and our answer will be in meters. Okay? So that was the rule here. We've done rule number 1, we've done rule number 2. I think now we've got to convert our time to seconds. So, times by 60, and that will be 1200 seconds. Now we go, do we have an equation that starts S equals? Look on the previous page and see if you can find an equation that starts S equals. VT, velocity times time. Step number 5, I think, sub the values in, 4.5 times 1200, and out will spit 5,400 meters. Well, it doesn't spit out meters, but remember back to this column, we had seconds, we had meters per second, so our distance will be expressed in meters, which we could convert if we wanted to. We could convert that to kilometers. It's 5.4 kilometers divided by 1,000. Okay? Next page. Oh, looky. You have a whole heap of questions you can now attempt. Use all those rules, gentlemen. And what I will say, though, let's just quickly work our way down. 1 and 2 and 3 do not require any conversions of units. Neither does number 4. Neither does number 5. Let's turn the page. Oh, hang on. We've got kilometers and meters per second. How many seconds? I would suggest... why are people shouting out? I would suggest that one will need to be converted. Okay? Next. Look, that one needs to be converted. That one needs to be converted. That one's okay. Oh, look, 10 minutes, meters per second, kilometer. All right, so those 10, 8, 7, and 6 will need converting. I'll just write that down over here as a reminder. Questions. Oh, I can't go backwards. 10, 8, 7, and 6. Yeah? Was that it? So just be aware, once you get to those questions, you are going to have to convert a unit or two so that you're in the same column. Okay? Now you've got the rest of this lesson to get these questions done. Yes, Ed?
You may suggest leaving our answers in one side or the other, or not?
Unless it's expressed. Like there was one question that says, what's the speed in meters per second? Then you have to. If it just says, what's the speed? Then it's up to you which one you want to express it. Just go 1 decimal for now. 1 decimal place is fine. And again, it might seem like a lot of wasted paper, but you have to show all of your working out. I do not want to see a single kid just writing 742.5, which is the answer. What? So 0.6. It is the right answer, but round it to 1 decimal place is fine. Okay? All right. I need to see. Let me just quickly look at the board, gents. When we get to the test, there will be like a 1 mark for writing the equation, 1 mark for subbing in the values, and 1 mark for putting the answer. This would be a 3-mark question. If there was some converting over here, then there would also be a mark for showing your conversion. All right, so it could be a 4-mark question. And if all you write is that, you're only going to get 1 mark out of 4. Okay? Even though you're a smart kid and you understand and you did the right stuff, you're not showing the marker. You've got to show the marker that you show your marker everything that you did, which sometimes is going to be in your calculator. Okay? All right, I'll stop the screen.